and space. Okay, I'll start again. My name is Ayelet Weizman, and I'm leading a track called Robots and Space Education in the MA EdTech program at Hakibutzim College for Education, where Dr. Betty Schreiber is the head of this program. And in this program, we have teachers, mainly teachers, that are coming to have their second degree, the MA. They come from various subject matters for all age groups. And my role is to teach them what computational thinking is. So what is computational thinking? It is a phrase that was made by Janet Wing. Actually, it started before, but Janet Wing gave it the main idea on 2006, when she said to reading, writing, and arithmetic, we should add computational thinking to every child's analytical ability. So what she means is that computational thinking is like another language. And with this language, everyone can create whatever they want. This is the idea that I would like to teach my students. There are four main principles to computational thinking, which include decomposition, like taking the big problem and dividing it to smaller problems, pattern recognition, abstraction, and algorithm design. So you can see that algorithm design may lead you to using code, writing codes, but the main idea here is not the code. The code is just the language that we use to create. So we start from the problem, we finish with the code. My goals in the courses that I teach one course in the first year and one course in the second year. And both of these courses use the same principle. One is just to teach what computational thinking is, the main idea and some examples. The other is a seminar or a final project that students make to finish their degree. And in this project, they can choose robot or any sensor-based technology with the principles of computational thinking to create something related to education. So I have many goals in these courses. The goals combine content, skills, technology, and pedagogy. In content, I would like to teach them what the computational thinking principles are, and also what the added value of physical digital technology is. And the skills are many. I teach them problem solving, and actually the main idea I use here is modeling. Everything I do in this course is an example for what they can do as teachers with their own students. So when I teach them problem solving, I want them to learn how to teach problem solving to their own students. Also collaboration, how to face challenges, how to cope with failure. This is very important. Failure is part of the process. You cannot succeed if you don't fail before. And the pedagogy that I use is mainly creative learning and design thinking. It's also project-based learning, but I think because we create something physical, it is more design thinking than project. So the technology that we use is, of course, coding, and we have several physical digital technology like microbits, and that I will show you soon what it is. We have sensors in the microbit, and we also have several types of robots that we use. How do I teach all this content? So I have a gradually increasing pedagogical line, and I try to scaffold it during the process. So first, the first project I give the students is easy. It is something that they need to create that will count steps, a step counter, or a physical activity counter, like what you see here is like a watch to count activity you do with your hands. And I give them the code, I give them the idea, the subject, and they only need to create the physical product. The second project is a little more difficult. Sorry. The second project is using sensors. And here, the students need to create a product that will use sensors and will have also a lesson plan for students. The third project is open. They should create a project with their own code. They create the code, they create the question, they find the question, and they try to solve a problem in their own teaching. It can be something that will help them in their teaching or the students for learning. So the pedagogical curves has increasing difficulty and decreasing scaffolds. And the scaffolds include instructions that I gradually decrease. There is the code. First I give them the code, then I let them change the code, and then they create the code by their own. And the content is also given, and then they have to create their own content. This way, it's not difficult even for students that come with no background, without any knowledge about computers or code. In this process, I use UDL principles in any computational thinking course. Actually, this is part of the idea of computational thinking, because I can use as a teacher, as a lecturer, various representations, various ways of expression, and various ways of engagement. For example, the course is hybrid. It was in the Corona term, it was mainly online. Some of it was synchronic, some asynchronic. When we can meet face to face, then we do the things that we have to do face to face, like using robots. Yes, you cannot use a robot remotely, but we have simulators, both for robots and for computational thinking. And here I can show the two types of codes that we use, the Scratch code and the make code. They are both types of blocks codes. You don't need to know what the block means. You only need to take the code and move it from place to place. I will show you, you will try it very soon. You can have your own experience. So we have various ways of expression. They can choose which code they want. They can choose which robot they want to use, and they can use the sensors or other ways to express their products. The engagement.
Ayelet, you have a question. Can you say it now, please?
Okay, I'll look. What is the second code? Scratch and make code. It is called make code. This is the one that you are going to experience very soon. It is very similar to Scratch. And as to types of engagement, the university students are engaged both as students and as teachers. In their projects, the products are for their own students, and they have to try it and see the behavior of their own students. So here are some ways of engagement. We use what I described before was the simulators the simulations that we use online, but we have lots of ways to engage face-to-face. Some of them are in the classroom, like trying some making products, and also in the media lab. We visited the media lab of Dr. Oren Zuckerman at the Herzliya College, and we also took the students for a trip to the Mitzpe Ramon in Israel. This is a place which is very special because it is one of the international places that are that can give you some similarities to Mars. It is used as a place to research Mars for analogical research. And since I'm teaching space, also space education, so I use this place both to teach about space and about sensors and robots and computational thinking. The students engage in this place and they really feel like astronauts. They wear the costume and they had the helmet of an astronaut. They use the sensors and they go to the area to search the temperature, to sense the temperature, the light, and the ground. And then when they come back to class, they can create projects for their own students using what they learned in the area. And now I will show you some examples of the final projects of the students. So some students chose the topic of language learning. And in language learning, you can use microbit, which is this thing I can show you for a minute in my, if you can make this bigger and see, this is a small card, very small, like smaller than my hand, and it has sensors on it. This is what we use. Going back to the presentation. And as you can see here, the student holds this ticket, this microbit, and when he presses the button A or B, he can see some lights. The lights show him if he is right or wrong, or show him some way of continuing in his task. And the task here is about letters. These are letters in Hebrew, and the A and B are the button that he needs to press. Another example is math projects. These are two examples. One in Scratch, where students use the pencil and the axis, the numbers, to teach about negative numbers. And the students have to solve equations with the, like holding the microbit, moving it, and then the pencil will move on Scratch, on this simulator. And another, this is a physical product with the robot TinyBit that drives on the axis and shows what is multiplication. If you add 2 and 2 and 2, it's like 3 times 2. That's what they learn watching the TinyBit. And the teachers tried it in their classroom and they came back with lots of ideas and the conclusions. Here are some other products that were using sensors, the sound sensor. For example, here, two teenagers are talking. If they talk very loud, then the sound sensor is showing them a red light. If they talk silently, they see the green light. And this is how you can see during a conversation whether you are talking too loud or shouting. So it helps students in conversations and solving problems. For example, this project is with the temperature sensor, and students see, when they see the smiley face, a sad face, they know the temperature for this animal. There is some kind of a snake here. So the temperature is too low. If the temperature is good, they see this sign. And this project is using the angle sensor, and they learn in mathematics about what, it's actually in science, they learn what an angle is and they can change it. Some other examples are about students that made their project especially for students with special needs. In our program, we have students, we have a track for special needs. And in here, students decided to use various types of robots to solve problems for their own students. So we can see there are lots of ways for expression in these courses. For example, students with special needs need to know how to write a letter, and they used this robot, Sphero, in order to learn the way to write the letter Reish in Hebrew. Another example is this robot that is called TinyBit, and they use the robot to teach students with special needs how to wait in line and not jump ahead. And they did it while the student was repeating what the robot did and copying the behavior. And then he needs to wait for the robot, and then he does his own act. Another example is with the robot Timio that you can see here. This robot is using different types of behaviors. It is very good for young students and for students with special needs. And in this project, students had to choose which behavior of the robot is best to solve a problem. So they could choose which robot is convenient for them, and they showed their students how to choose the best behavior. So we have two levels of choosing and expressing yourself, the level of the student and the level of the teacher. And the last one, the last example, is a project with the robot that is called EV3. It is a Lego robot. And here they wanted to teach special need students about hand-eye coordination with the robot. So the robot is moving and it has a pen attached to it. So the pen is drawing this shape, and then students have to copy the shape in their own notebooks. And then after they try some shapes, they have to create a shape and teach the robot how to copy the shape that they created. So the process of creating these products was not easy. It was full of challenges, and the students had to do it step by step with the scaffolds and help from mentors that we gave them. But the feeling after finishing and representing their projects in a special representations day was a great feeling, and they expressed it in their feedback for us. So now I finished my talk, and I want now you to experience how to use the microbit, how to use computational thinking to make your own project. And now my TA, Ori, that is here, Ori Pelkin, he will help me in teaching you, in helping you, mentoring you in creating with MakeCode. So what do you think? Should we split to 2 rooms, or should we do it in 1 room?
I think we should do it in one group.
In one group.
Yeah.
So first, we will take about 10 minutes to explain to you how to use the environment, the MakeCode environment. So now the question, Ori, do you want to do it?
Yeah.
Great. I will write in the chat, I will write the, just a minute. I will give you the link. Sorry for my English.
You have perfect English,
Okay.
Ayelet. Perfect.
Hello, my name is Ori. I'm a student in the Seminara Kibbutzim College in Ayelet Weizman's course of computational thinking. And I will explain about the MakeCode site and the programming environment of the microbit. I will share my screen so you can see every action that I do and you can repeat in your computers. First of all, I am going to enter the site mycode.microbit.org. Ayelet sent the link in the chat. And the first thing I will do is start a new project and name it. Okay.
Do you need to sing into the computer in the computer site?
I think not.
I will check.
I think not. I think you can enter it.
Yes, we don't need.
Yeah. So I am starting a new project. This environment is block coding environment. I don't know if some of you know the block code already, but I will explain so you can do the little mission we have for you. We can see we have two different areas, one of the microbit simulator here, and one for the coding. Each action we do in the coding area, we can see in the simulator area. For example, I can take from the basic show icon, okay? And if I'm going to put it here, and I can see that the simulator is already have the heart icon in it. Okay, so we can see every action we do in the programming in the simulator area. And we have a lot of different categories, and each category has its own color. So in the coding area, we can know which category we chose from. The first category is basic. It's the basics of the programming, mostly the showing of stuff. We can decide if we want to make our own shape. Okay, I can press here and make a shape. And if I want to erase one of the LEDs, I just press it again and I get my new shape. I can also take from the basic show number and show string. This works only in English. And it will say hello in an instant. Okay, each letter separately. Okay, so another thing that I will say that, as you see, forever will make the action run in loops, and if I make it just on start, it will do it once. Okay, we can see that it will say hello to us once and stop.
Maybe this is the time to show how you can choose the language. If you want to be in Hebrew or Arabic or Spanish.
Yeah, I have the settings here, and I have a lot of settings. And one of the settings is language. So I can choose any language I want. There is a lot of languages here. There are. Next thing I will explain is the input part. The input is what is the interactive part of the programming. I can choose to press on button. I have A button, B button, and AB button. And as I chose this option, we can see I have the AB button on the simulator. And to make the input count, I need to choose what the input will do. Okay, so I can choose music. Okay, I can choose to play a tone. I can choose to play a melody, and then I can choose which note I want. Okay, and it will play it. And I can choose from things they have here. Okay, this is the music part. The loop part is an option that I can use if I want something to repeat itself. Okay, if, on the press I want him to show a heart icon, then I press. Wait a minute, it will. I press the A and B button, and it will give me heart 4 times, and then it will stop. The logic part is if statements. I can use it if I want to use my sensor. Okay, I can use the sensor in the input section. I can choose a light level. Okay, and then I can tell him that on button press A, and then take from the logic the if else part. And as you see, I have light level in a circular shape and true in a different shape. So I need something else. Okay, I take it from the math, from the logic part. Sorry, the bigger. Okay, and then I can set the light level. If the light level is bigger than 100, I can tell him to make a heart icon. If it's not bigger than 100, I can make him do another icon, like a sad face. And now when I press
explain how you can duplicate.
Oh, right. If I want to duplicate this action of show icon, I can press the right mouse button and just duplicate the action and choose another icon. Okay, now when I press A, I can see the light level sensor here, and with my left click on the mouse, I can play with it.
So it is, we need to explain, since you showed it, that this is a simulator. It's not really sensing the light in the room, but the real thing, the microbit, is really sensing the light in the room. So in the simulator, we just can play with the amount of light.
Yeah, and one last thing I want to show you is that in the input, I can take the on shake option, and there is a lot of option in here. I can shake it, rotate it, screen up. This is not a very good option for the simulator, but I wanted to show you all of the options. Ayelet, do you want to add?
Just explain that we have here different types of expression, like in UDL, and students can choose whatever is fitting, is best for them. You have, like Ori showed you, you have music, sound, you have text, you can write letters, If you want to write in Hebrew, you will have to take from the basic, maybe you should show how to write a letter in the letters. And you can also use, so I said you have sound, you have text, and you also have shapes. And the sensors of light, temperature, they add some more expression ways. So it is very rich in ways of expression. And I guess it was a little too much to understand in so little time, but that's why we prepared something for you in advance. And this is another thing that is very recommended about the make code, that you can make, or we maybe show them how you can
share my project.
You can save your project and give a link to it to your friends. And then your friend can use the link and make their own project on the project you gave them. So this is the principle of remixing. If someone knows Scratch, Scratch has the principle of remixing, and it is very recommended in this area of computational thinking. It is very recommended to copy from one another. It is not forbidden to copy. You can do it. And that's one of the advantages of this area. So can you show how to share?
Yeah. I will say that I make the letter Aleph. This is my first letter in my name. And see how when I added the shake, in the simulator, there is a shake option. I can press on it and see the action. So the share option is on the upper board in the blue area, and I can just share. I need the name of the project, and I can publish the project. And then I can copy the link and send it. And also we have a QR code here. I can send you this project. I think I will send them the project you made, Ayelet, because it's richer.
Okay, do you have it? Do you have the link?
Yeah.
Good.
Ayelet, we have 25 minutes more, so just
so
be
now
aware for the time.
In the next 20 minutes, you are going to try and express yourself in make code. So
Harry wants to ask something.
Yeah, I just, first of all, I want to thank you. I don't think you're putting too much. I think it was extremely valuable, and thank you to Ori. I may have missed it. Where can we get the little plastic,
microbit?
I don't even know what you call it, the microbit.
Microbit.
Where does one get that? You buy it online?
Sure. You can buy it online. It is the cheapest way is to buy it online. It's about $10, something like this. If you like us, if you're a college and you need to buy it from a vendor, so there are some vendors in Israel that sell it. Then it will be like 100 shekels for.
Okay. I just thank you for giving me something to do in the summer. Really, it's just really.
You have to be careful. I must tell you, you have to be careful, because this is addicting. When you start with the microbit, you cannot stop. So please now go to the link.
I want to show one more thing. When I open the link, you will get this screen, and you can press here, edit code, and then you can edit your own code.
Yeah. So what we ask you now is to go to this link, copy the code, press edit, or what you have there two options for pressing edit, And then you will see that you can change the code. Before changing, you can just look on the simulator, or maybe you can still share your screen, and everyone will try to do the same on their own screen.
Wait a
And
minute.
you can change it however you want, express yourself with
Right now, the example is in Hebrew, and for those who can not read Hebrew, I think you should change to English.
You can change the language here in the setting. The language will change.
Okay.
Press the language like Uri shows you, and then you can choose English or any other.
Okay. I just make a remark for those who can read Hebrew.
Thank you. It's important. And then if anyone has a problem, you can share your own screen. Betty, can you let anyone share? Oh, I see it is possible.
Yes, I think it's possible.
So if someone wants to, if any one of you wants to share the screen, and we can solve problems and help you.
So I'll stop my screen sharing, and now if you want, you can.
Maybe just that we don't have nothing on, so we don't have nothing on the screen. We can show something from our screen, just examples.
Maybe one of the participants wants to share and show us what he or he is doing. Anyone want to share?
If I want to create like a language game, like matching a word to a translation or something, so how do I do that?
So you first need to treat it like a computational thinking problem. So you use the principles of computational thinking. First, you define your problem, okay? And try to divide it to smaller problems. So what do you want the student or the participant to do first? You want them to see letters, you want them to see
a word, and then a translation, for example, for English, matching English word to a Hebrew word, for example.
Okay, so first I must tell you that you need to prepare in advance the translations. It will not connect to a translator by itself. Yes, you need to make an array. It's a little advanced. You need to make an array of words and the translation to these words, and then you should think how you want the participant. Maybe he will touch he will see words, he will touch a button, and then they will see the translation.
Like A or B, like giving him a word and like two options, like in the example that you showed, two options, and then the participant has to choose either A or B depending on the correct option.
So this is an example that two of my students made like in their product. It took them some months to create it, several months.
But we do have 20 minutes.
But it's not difficult. Actually, you can do it very quickly. You just need to be a little more experienced with the coding. Okay, so you need to make an array and to choose a button, and actually it's not difficult.
Okay.
There are also options to look in the internet for projects. Like you write in Google microbit projects, word projects, translation project. I'm sure you will find examples, and then you can change them.
I think that will be a good start to starting for something ready, building upon that, and then creating my own like progression.
Right. It helps a lot to remix.
Thank you.
Anyone else wants to share or ask? Don't be afraid.
Yes.
I start using making my own project. I can share what
Thank
what
you.
I
Share.
start.
Please share.
So yeah, just a second. So can you see my project?
Yes.
Okay, so for start, I
You're
say
Hebrew speaking, so you wrote it in Hebrew. Okay.
I change it to English. Sorry. So for start, the micro bit will say hello, and after this, I start to program what happened when the button A is pressed, or when button B is pressed. So I just start with designing that when I press the button A, it will play a melody. Tempo melody.
But you didn't choose the melody. So now
No.
press the melody.
Press
the melody and now create it. Just create the melody or choose it from the gallery. Yes, you can choose from the gallery.
From here? This is
yes.
Here I can choose?
Yes. Mystery.
Okay. That will be.
Now,
and now I just want to program what will happen when I press the button B. So when I press button B, I wanted to. This is the lad is how I programmed for how it will be displayed on the.
No, take the basic category.
Okay. Mm-hmm.
Yes, and
okay.
now show LEDs or show icon.
Okay, so it will, and then it will be. If I will press the button B, it will show and heard.
Right. So can you share the sound so we will hear the melody? You need
That's it. This is the melody.
Nice.
Okay. I must say that I want to to play much more time to see how can I choose the different functions of the program, but it's very simple. You don't need to understand computer
right.
computers the programs to how to design it, but it's very nice. I'm from system. I'm a system analyst, and it's very easy, and I can see how can I work with my son in the summer.
Sure. It is very friendly.
Yeah, very much. I will stop to share, so maybe someone else will.
Thank you, Judith. That was really interesting.
Thank you. I very like it. I like it very much.
Great, and it's really easy for us, for adults, but it's even easier for kids and students. They really catch it immediately and they create very nice, interesting, and expressive and creative products. It's really nice to see what they do.
I would like to my final project will be with robots, and I want to work with my son about the planning for planning stuff that he has difficulties in this with planning, and this for me this is a good start to see how can plan now, and then I study how the robots can help and realize if it will be better or not.
Right. So I didn't say that some of the robots that we use are based on microbit. So after you feel more secure, or you feel better with the microbit, then you can order your robots online.
Yes.
And the
I will
robots,
like it.
it's like games. It's really easy to use. And after you know how to use the microbit, you just put the microbit in the robot and it will do whatever you want. This is really the games for the future,
Yes.
the 21st century games.
Yes, yes.
Ayelet, I was not quite understood about what is the AB, because there is A and B and then AB.
Right.
So AB, it's the connection between
in the microbit, you can press either A or B, but then you can press them both together. A and
it's a combination of these.
It's the combination. But in the simulator, you cannot press them together, so they made like a button that is A plus B.
So the simulator is doing it automatically. It's the combination.
It gives you like a third button.
Can I show you mine, because I'm not sure. I know that I made a lot of mistakes.
Please show us. No,
I have to show you.
You know that mistakes are part of the process.
Yes, I'm sure. Okay.
You have to press.
Yes, like this here, right?
Yes.
So I made this. Say love you, and they smile.
Yes.
This is the melody of birthday, and this is I didn't touch. And now, what is the AB regarding to this? What should I do? I made I made this hard. I made it, but it should be automatically take from
it's
B
not
and A.
It's not taking it from another block. It's different. When you press B, it will do whatever you put inside the loop. When you press A plus B, it will do another. It's not the same. It's not connected.
I see. Okay, thank you.
So let's see. Let's show us how it works.
Let's see. A.
The melody. We need to hear the melody. So maybe you didn't share the sound.
Not forever, right? Once.
Okay.
Okay, again.
You didn't share your sound, so we don't.
I didn't share my sound also. Okay, just a moment. I will share it, but it's too long. Here.
Okay. This is a great birthday present to you.
And now I should go to B to see my heart.
So it says
love you, love you, yes.
And
smiley. Yay!
4 times. And now press A plus B.
Yeah. A plus B.
It should show us.
Yes, the heart. And I put it a plot. I don't know what is it. Just try it. I don't know.
Yeah, so I think it cannot do it without the other
okay
code.
But it's
it will
very
do
nice.
heart.
Very nice.
We get the heart.
I enjoyed the birthday.
So now you can give your grandson, or granddaughter, the birthday present.
Right. Thank you.
Okay. Does anyone else want to share? If not, I can just show you something about the make code. Where is it? Is it this? No. I wanted to show that you have in make code lots of projects that you can try. If you become addicted and you want to learn what else you can do here, then go to the main.
We can see your, okay. Right.
Can you see now? So you go to the main link, and then you go down, you scroll down, And here you have tutorials.
Oh,
Very easy. For example, flashing heart, you press it and then you can play a video lesson or start tutorial in blocks. Python and JavaScript is for advanced.
for
Start
programmers.
tutorial in blocks. And then I just need to copy what they show me. It's very, very easy to learn. Okay? Learn how to use the LEDs and make a flashing heart. Okay. And then you see they tell me what to do. And even if I don't succeed, if I don't understand, I just press the light bulb and they show me what to do. And then I press next. And step by step, I learn what to do and until I have a flashing heart. So it is very, very easy to learn with microbit. Oh, I'm out of the program. And so we have these tutorials and okay, I'm just stuck in the tutorial. So here are the tutorials and you have lots of games like a dice. You can make a dice from your microbit. You can have a love meter. It will tell you if someone loves you. You can make a name tag and microchat. I'm not sure what it is. And then you have lots of videos that shows you how to do a compass, red light, green light, tag of lead, different games. And then you have radio games. Radio games is using 2 microbits. So for this, you need to buy 2 microbits and play with them. And you can make connections between them. So 1 microbit can have the input and transfer it to the second microbit. And there are lots of options with 2 or more microbits. Then you can add making and make, like we made the watch or a step counter, name badge, and you can create music instruments and toys, as you can see here, and you have the instructions how to make these things. And science projects using the sensor to water plants and to measure time of stopping time and etc. You have lots of options. I really recommend playing with microbit. It's this environment, this simulator is free. It was made by, no, I forgot the name. We have to give them the credit. Microsoft, together with the company, it's in England. Wow, what's their name?
Doesn't matter, Ayelet, it's okay.
BBC.
I just want to tell you that next
Okay,
time we have a team meeting, I invite you to do the unicorn toy I saw there.
Okay. So we will make the unicorn.
Yes.
And
if I would like to buy the microbit, I just buy from the web that we.
Yes, you just write microbit. Buying
because there are a lot of, I just saw that there are a lot of kind of microbits.
And it's mostly one, and recently they added another version, which is a little advanced, but you can use the first one. Maybe it's cheaper, just to begin. And I don't think there are more than 2 options. Okay. So just take the cheapest that you find.
And can they buy from Rami?
Of course.
Okay, maybe you will give them the.
I'm not sure. I'm not sure he will give the same price for individuals. The students.
For our students, I think
buy,
you will.
If you buy it for a classroom, and then you can buy 40 or a number, and then it may be cheaper.
After this, I will write a mail and
Okay.
ask for the
And,
for Rami phone
and of course, for schools, you can
Mhm.
use the same microbits with different students.
Yeah, of course.
It's not so easy breakable, so you can use it. And I think we have no more time, right? So thank you everyone for joining.
Thank you so much. Thank you so much. Ori, thank you so much.
Thank you, Ori. It was great.
I made you something special for you. Thank you so much for your time.
Thank you, Betty.
Thank you.
Thank you.
And have a lovely workshop at 3:45 with Amir Bar. It's a very interesting workshop. So I invited you again to this Zoom 8.
It's Zoom, okay. And where is the movie?
The movie, I think it's the main room, at the main room.
Okay, we'll go there.
Thank you.
Thank you.
all.
Thank you very much.